In the quiet darkness between the stars, something is moving, silent, ancient. A traveler from beyond our sun. Its name is 3I Atlas. It began with a flicker, a tiny, cold spark in the summer sky of 2025. Astronomers at the Atlas Survey Telescope in Chile saw it first. A light so faint it could have been just noise. But it wasn't. It was real. And it was wrong. Most comets orbit the sun, circling endlessly like icy ghosts. But this one was different. Its path cut straight through our solar system and out the other side. It wasn't a returning visitor. It was a wanderer from another world. Before we follow this cosmic traveler, take a breath, look up, and if you're new to Starsky Science, subscribe. Because tonight, we journey into the quiet mysteries of the universe. Astronomers call it the third interstellar object ever found. Before it came, we had seen only two. Oumuamua in 2017, a strange cigar-shaped rock that passed too quickly to study, and Comet Borisov in 2019, a frozen traveler, its tail glowing with alien ice. Now, in 2025, a new visitor has arrived. 3I Atlas, the third messenger between the stars. But unlike the others, this one was spotted early enough for us to watch its long, patient approach toward the warmth of the sun. Data from Atlas revealed something shocking. Its orbit wasn't closed. It was hyperbolic. That meant it wasn't trapped by the sun's gravity. It was simply passing through, too fast to stay. Its speed was nearly 90,000 kilometers per hour. Its origin? Somewhere far beyond our reach. Perhaps the frozen edge of another star's cradle. Scientists realized this small, icy traveler had likely spent millions, maybe billions of years drifting through interstellar space. Cold, lonely, untouched. Imagine it. For eons, 3I Atlas sailed through darkness, crossing the invisible borders between suns. No light, no warmth, only dust, radiation, and the silent pull of distant gravity. Until one day, our sun's faint glow reached it, a spark in the void, and slowly, the traveler turned toward the light. As it entered our neighborhood, scientists everywhere turned their eyes skyward. For them, it wasn't just a comet. It was a message from another solar system. A frozen time capsule carrying secrets older than Earth itself. Spectrometers, telescopes, orbit models, all focused on a single point in the dark. Each frame captured, each photon measured, revealing the chemistry of a stranger. 3I Atlas began to brighten, not from sunlight alone, but from activity. Jets of gas bursting from beneath its crust, even while still far from the sun. That shouldn't happen. Most comets sleep until sunlight warms them, but this one was already awake. It meant that inside this comet were ices more volatile than water, gases like carbon dioxide and carbon monoxide that evaporate in the deep cold of space. That discovery changed everything. It suggested that 3I Atlas was born in a region colder than any part of our solar system, a place where sunlight never reached. Every fragment of gas, every grain of dust escaping from it was a clue to its lost home system, to a star that may no longer exist. So here we are, watching an ancient traveler, a fragment of another dawn, as it passes silently through our cosmic backyard. For a brief moment in eternity, our worlds cross paths, and we listen, hoping to hear what it whispers about the stars. Every object that enters our solar system follows a pattern. Bound by the sun's gravity, they orbit, they return, they belong. But 3I Atlas did not belong. It came from nowhere we could name, and it was going somewhere we could never follow. Its orbit was open, its path cutting through the plane of planets like a blade of light. And as astronomers traced it backward, they found no home, no star, no familiar route. It had come from the void, a stranger among our family of worlds. Oumuamua had confused us once before. That mysterious rock from 2017, long, flat, and fast. Its shape and spin defied everything we knew. Some thought it was natural. Others wondered if it was built. But it vanished before we could decide. Then came Borisov in 2019, a true comet, glowing with water ice, a messenger from another star system. Its chemistry both alien and familiar. It showed us that other worlds could form comets too. And now 3I Atlas, different from them both. It is neither a silent rock like Oumuamua, nor a water-rich comet like Borisov. It is colder, darker, filled with carbon and gas that escapes in the dark. Its story, written in its ice, belongs to a system unlike our own. As telescopes observed it, scientists began to realize something profound. This was not just a comet from another star. It was evidence that planetary systems everywhere create, destroy, and scatter their debris into the endless interstellar sea. Perhaps when its original star was young, worlds were forming around it. Gas and dust swirled together, and collisions sent fragments flying into space. 3I Atlas may have been one of them, a small piece thrown out in the chaos of creation, doomed to drift forever. For millions of years it wandered, between stars, through clouds of dust and radiation, no gravity to pull it home, no light to warm its frozen skin. Only the silence of space, a silence so complete that even time seems to stand still. When it finally approached our sun, we became its audience. For the first time, a stranger became visible, an emissary from another origin. And yet, despite the distance it had traveled, it seemed so fragile, so delicate against the dark. A reminder that even the oldest travelers can be broken by a little sunlight. As it drew closer, its frozen heart began to stir. Jets of gas escaped from cracks in its crust, forming a faint tail behind it. But not the bright, shimmering tail of water we expected. This one was pale, thin, made of carbon dioxide, a signature of deep cold. Its chemistry told us a secret. 3I Atlas had never known warmth. It had formed in the farthest reaches of its home system, where light was nothing but a whisper. Its birthplace may have been a ring of ice and dust around a small, dim star, perhaps a red dwarf, perhaps one that died long ago. And now, across the gulf of time, that same fragment of ice had come to us, a memory from another sun carrying the fingerprint of its creation. Astronomers studied it day and night. Every molecule escaping from it was recorded, measured, analyzed. Carbon monoxide, carbon dioxide, traces of organic compounds, all the ingredients that can build life locked inside a frozen traveler. It was as if 3I Atlas had carried across the galaxy a recipe not for life itself, but for the chemistry that makes life possible. Some scientists began to wonder, what if interstellar comets like this were the seeds of life itself, thrown from young solar systems, drifting for ages until they land in new worlds, bringing with them the elements of creation? If that is true, then perhaps every world in the galaxy is connected by the same cosmic thread. Frozen messengers like 3I Atlas, passing from one sun to another, scattering life wherever they go. We have only begun to understand it, but as this mysterious comet passes through our sky, we are reminded that we are not isolated. We are part of a larger story, a web of stars, worlds, and travelers that exchange dust and dreams across the galaxy. And 3I Atlas, the stranger that came uninvited, is one small proof that the universe is alive with motion and memory. Every comet carries a memory. Inside its frozen shell lies the story of its birth, the dust of its star, the ice of its home, the chemistry of its creation. 3I Atlas is no different, but its memory is not of our sun. It belongs to another, a distant, vanished star, a place that once burned with light in a corner of the galaxy we may never reach. When scientists studied its chemical makeup, they found it was rich in carbon dioxide and carbon monoxide, but poor in water. That meant it had formed far from any source of warmth, in the outermost edge of its home system, where the light of its parent star was little more than a glow in the dark. In that deep cold, dust and gas would have gathered, grain by grain, slowly building into a ball of ice and rock. For millions of years it grew, frozen and untouched, circling its young star in a wide, silent orbit. Then something changed. Perhaps a giant planet moved through that system, its gravity scattering smaller bodies outward. Perhaps another star passed nearby, its pull tearing comets away from their home. Or perhaps the star itself aged and died, its final light releasing its icy children into the emptiness between worlds. Whatever the cause, 3I Atlas was thrown free, set adrift on an endless journey through interstellar space. It became a wanderer, cut off from its origin, drifting between stars for eons beyond counting. Imagine that journey. No sunlight, no warmth, only the endless night of the galaxy. Each year, it would cross trillions of kilometers, passing through faint clouds of gas, through invisible dust lanes, through the quiet glow of distant starlight. In that darkness, it carried the fingerprints of its creator, the atoms and molecules that once belonged to a completely different world. It was a time capsule, a messenger of another beginning. For billions of years, it drifted unnoticed, a frozen ghost among billions of stars. And then, by the smallest chance imaginable, it found its way to us. Our solar system, one of countless ports in the sea of stars. And here, our sun's gravity caught it for a brief moment, pulling it into a curve of light and warmth. For the first time in ages, its frozen body began to change. The surface warmed, hidden gases beneath the crust burst out into space, forming a faint, glowing cloud. It's coma. The ancient ice, untouched for eons, was now exposed to sunlight once more. To the astronomers watching, it was like seeing the breath of another world. Each molecule escaping from it was a relic from its forgotten home. Every trace of gas told a story about the temperature, the pressure, the light of the star that once gave it life. And through these whispers of chemistry, we could imagine what that lost system was like. Maybe it was a dim red sun, surrounded by a disk of ice and dust. Maybe it had planets, some rocky, some gaseous, some now long gone. Maybe it had its own version of an Earth. And maybe, just maybe, the same ingredients that made life here were once present there too. 3i Atlas is a reminder that the universe recycles its stories. Stars are born, live, and die. Their remains become dust in ice, and from that dust, new worlds are made. Sometimes the fragments of those worlds escape into the void, and when we find them, we hold in our hands the history of a distant sun. It's humbling to realize that the same elements we study in 3i Atlas are the same that make us: carbon, oxygen, hydrogen, nitrogen, the basic building blocks of everything we know. Across light years, across ages, the universe keeps reusing its ingredients, shaping them into new stars, new planets, new life. So when we look at 3i Atlas, we are not just observing a comet. We're looking at a mirror, a reflection of our own beginnings, forged in another dawn, under another star. It tells us that creation is not unique to us. It happens everywhere, in every corner of the galaxy. And though we may never see its home, its chemistry speaks to us, a soft echo from another sun, reminding us that we are part of something much larger than our small circle of light. The traveler moves on, but the knowledge it brings remains. And through it, we catch a glimpse of the grand pattern that binds all worlds together. After billions of years in darkness, 3i Atlas finally met the warmth of a star again. Our sun, a familiar fire to us, but to the comet it was a blazing giant, a force of heat and radiation it had not felt since the birth of its original world. As it entered the solar system, it crossed the orbits of distant planets, first Neptune, then Uranus, its icy shells still quiet, still frozen. But with every million kilometers closer, the sunlight grew stronger. Its surface began to awaken. Tiny cracks opened in the ice. Gases trapped for eons hissed into space, creating faint, ghostly tails of vapor. It was as if the comet was breathing again, exhaling the frozen memories of another sun. From Earth, telescopes captured its glow. It wasn't as bright as expected, but it was different. Its shape, its orbit, its behavior, all told scientists this was no ordinary comet. It had come from far beyond, from the space between stars. Astronomers compared it to another traveler, known as 2I Borisov, which had passed through our solar system a few years earlier. But Atlas was different. Its orbit more chaotic, its surface more fragile, its chemistry more complex. It seemed to carry scars of radiation, as if it had survived countless cosmic storms. As it neared the inner planets, something began to happen. The sunlight struck harder. The surface temperature rose rapidly. Gases deep inside began to expand, creating pressure beneath its crust. Then, without warning, the comet began to break apart. One day, it was a single glowing dot in the sky. The next, it had split into fragments. Pieces of it scattered across space, each still glowing softly, each still carrying the ancient materials of its distant origin. For scientists, this was both tragic and fascinating. They were witnessing the death of an interstellar visitor, a cosmic relic disintegrating under the power of our sun. But in that destruction came revelation. As it broke apart, its inner material, once hidden beneath layers of ice, was exposed to observation. Spectrometers on Earth detected unfamiliar patterns, ratios of carbon and oxygen that didn't match anything formed in our solar system. Its dust grains reflected sunlight in unique colors, suggesting minerals never before seen in any local comet. It was like opening a time capsule and discovering a completely different kind of chemistry, one shaped by another star's environment, another temperature, another kind of light. Some of its dust grains contained compounds that could only form under the mediation of cooler stars. Others carried signs of organic molecules, simple ones, but important ones, the building blocks of amino acids. It was a small but powerful clue that the seeds of life might not be unique to our own corner of space. If such molecules could survive billions of years traveling between stars, then the universe itself might be filled with these tiny packages of potential life, drifting silently through the dark, waiting to land somewhere warm enough to begin again. The idea is called panspermia, the theory that life, or at least the ingredients for life, can travel through space on comets and asteroids. And 3I Atlas became a quiet piece of evidence in that cosmic puzzle. When it finally crumbled into dust, its remains formed a faint trail of particles, stretching across millions of kilometers. Some of those particles were pulled by solar wind, scattered into the void. Others fell toward the sun, burning away in the light. But a few, so small they could barely be seen, were caught in the gravitational current of our system, destined to drift for centuries, before finally falling toward the planets or being drawn back into the vast darkness between the stars. In that moment, 3I Atlas became part of us. Its story merged with ours, its dust, perhaps one day landing on Earth, carrying within it the chemistry of another sun. The comet's end was not a tragedy. It was a transformation, from a silent traveler to a messenger, from a frozen relic to a bridge between two distant worlds. And as it vanished into the glow of the sun, we were left with a question. How many more travelers are out there? How many more fragments of forgotten worlds are passing through our solar system right now, too small to see, too fast to notice? The discovery of 3I Atlas changed our understanding of the universe. It proved that interstellar objects are not rare. They are everywhere. We just hadn't looked closely enough before. Each one could be a messenger from a place we can never visit, a story from another dawn of creation. And perhaps, in the endless ocean of stars, somewhere out there, another civilization is watching a comet from our own system pass briefly through their sky, and wondering, just like we do, what secrets it carries from our distant sun. When 3I Atlas faded into the sunlight, astronomers didn't stop watching. They turned their eyes and instruments to the space it had come from, searching for traces of its path. And what they found changed everything. At first, it seemed like chance. A comet from another star, passing by at the right moment, seen only because our telescopes happened to be looking in the right direction. But the data told a different story. When they mapped its orbit and compared it to that of Oumuamua and Borisov, they noticed something unusual. The directions were different. One came from the constellation Lyra, another from Cassiopeia, and the now Atlas from Sculpture. 3 travelers, each from a separate region of the galaxy. And yet, their speeds, their compositions, their trajectories through interstellar space all seem to follow the same mathematical curve, a pattern too perfect to ignore. Scientists began to wonder, what if interstellar comets aren't random? What if they come from a specific kind of birthplace, a region of the galaxy where dying stars throw out their frozen debris like seeds into the dark? They called it the interstellar stream hypothesis. It suggests that when stars reach the end of their lives, their planets and comets are often ejected by massive gravitational shifts. Over millions of years, these ejected fragments form invisible rivers of objects flowing through the Milky Way. If this theory is true, then 3I Atlas wasn't just a lonely wanderer, it was part of a current, a stream of frozen relics drifting quietly between stars. And that means somewhere out there, there may be billions of other fragments, traveling unseen through interstellar space. Some on paths that will one day bring them close to Earth. For astronomers, this was both thrilling and humbling. It meant our solar system is not isolated. It is part of a larger cosmic circulation, a galactic ecosystem where materials, molecules, and maybe even life are exchanged between stars. Every new discovery confirmed it a little more. Tiny shifts in brightness, faint trails of dust, odd detections in telescope data all hinted at passing interstellar bodies too small or too faint to see directly. One by one, scientists began finding possible candidates. Not all were confirmed, but each clue pushed them closer to understanding how common these visitors might be. In a single decade, humanity went from knowing of none to discovering 3 confirmed interstellar objects and predicting the existence of thousands more. For the first time, the idea that worlds share their dust, their ices, and their organic molecules became more than theory. It became measurable. It also opened a deeper question. If comets can travel between stars, what about the seeds of life they might carry? Could fragments from distant systems have landed on Earth billions of years ago, bringing the first molecules that sparked biology? If so, then maybe life on Earth isn't completely of Earth. Maybe part of us, part of our chemistry, was born under another sun. 3I Atlas reminded us that the universe is not divided by distance. It is connected by motion. Stars die, planets scatter, and fragments drift endlessly until one day they meet again. The story of Atlas didn't end with its disintegration. It became data. Numbers, spectra, light curves, all stored in observatories across the world. And in that data, astronomers found rhythm. Every few decades, something similar passes through. Not always bright enough to see, but enough to leave traces of dust to disturb the space around us. It was like hearing faint footsteps echoing through the galaxy, reminding us we are not alone in motion. With better telescopes, like the Vera Rubin Observatory, and new sky survey satellites, we are preparing to see them more clearly. The next interstellar visitor might be already on its way. Maybe a fragment of another planet or the icy remains of a moon that once circled a forgotten star. And when it arrives, we'll be ready. Ready not just to watch, but to learn, to catch a piece of another world before it slips away into the dark again. The pattern is there, hidden in the quiet drift of dust and ice. A pattern that links the death of one world to the birth of another. A pattern that says the galaxy is alive, not in the way we imagine, but through motion, through sharing, through time. And somewhere in that silent rhythm, the dust of 3i Atlas continues to move, orbiting the sun for now, until gravity slowly lets it go back into the vast, waiting dark. The story of 3i Atlas did not end when it vanished into sunlight. In truth, it began a new chapter for humanity. Because now, astronomers knew something important. Interstellar visitors were real, and they were coming more often than we had ever imagined. For centuries, we thought our solar system was quiet, separated from the rest of the galaxy by endless distance. But after Atlas, that illusion began to fade. Now, scientists could see the faint signs of others, tiny objects slipping through space, barely noticeable, but following the same strange hyperbolic paths. They called them future visitors, and they could arrive at any time. The first goal became clear: to find the next one before it arrived. The sooner it was detected, the more we could learn. We could study its chemistry, its speed, its rotation, even send a probe to meet it in deep space. For the first time in history, humanity started to prepare a mission not to another planet, but to an interstellar traveler. Space agencies in the United States and Europe began designing fast, light spacecraft, machines capable of catching up with an object moving faster than any comet we had ever seen. They would wait quietly in orbit, ready to launch the moment a new visitor appeared. It would be a race against time, a cosmic chase. But the reward could be extraordinary: a chance to touch material from another solar system, to study the dust and gas of another star without leaving our own. Imagine a probe intercepting a comet from another world, collecting samples as it races past, then bringing them home to Earth. Inside those tiny grains of dust could be molecules older than our sun, or materials formed under alien skies. Scientists dream that one day such a mission will tell us how other planetary systems form, and maybe even how life begins elsewhere. It is a long dream, one that may take decades to complete, but every step toward it begins with a single discovery, a single faint light in the dark. The search has already begun. The Vera Rubin Observatory in Chile is preparing to scan the entire sky every few nights. Its cameras are so sensitive, they can detect moving objects billions of times fainter than the human eye can see. When it begins operation, astronomers expect it to find dozens, maybe hundreds of interstellar objects each year. Each one will tell a different story. Some may be rocky like asteroids, others icy like comets. Some may come from young star systems, still filled with dust and gas. Others could come from ancient ones, where the stars have already died, leaving only frozen debris behind. And then there is the most exciting possibility, that one day we might find something built, not born, not a comet, not a rock, but something artificial, something made by another civilization. When Oumuamua was first discovered in 2017, some scientists wondered if it could have been a probe, a piece of alien technology passing through our solar system. No one could prove it, but the question stayed alive in the minds of many. If objects can travel between stars, and if intelligent life exists elsewhere, then maybe some of those travelers are not natural. Maybe they are messages. Maybe they are explorers, just like us. It is only a possibility, but a powerful one, because for the first time, our technology is good enough to find out. New telescopes like the James Webb Space Telescope and future observatories planned on the moon will allow scientists to study the chemical fingerprints of interstellar visitors in detail. We may soon know whether their materials come from familiar processes or from something entirely new. And if one day a future visitor shows signs of artificial structure, we will know that we are not the only ones reaching out into the dark. Until then, each new discovery is a reminder. The universe is alive with motion. Stars form and die. Worlds are created and destroyed. And across that endless cycle, objects like 3I Atlas drift quietly, connecting one star system to another. Maybe that is the real message, that even in the vastness of space, everything is connected through gravity, through dust, through time. Our solar system is just one island in a sea filled with countless others. And as we watch these travelers pass, we learn not only about them, but about ourselves, where we came from, and where we might one day go. 3I Atlas showed us that the boundaries of our world are far wider than we thought. The next visitor will remind us again. And perhaps one day, when our own spacecraft leave the solar system for good, they too will drift through interstellar space, becoming someone else's visitor, someone else's mystery, someone else's discovery. Long after 3I Atlas had vanished from our view, something of it remained. Not the bright tail, not the icy core, but dust. Fine, invisible grains drifting through the quiet sea of space. Each particle was small, no larger than a grain of sand, but together they carried the story of a world. A story written in atoms and ice, in the silent chemistry of another sun. For scientists, this dust was not just debris. It was a message written in the language of the universe. Every speck of it contained clues about where it came from. Some grains were rich in carbon, others in silicates and frozen gases. Together, they painted a picture of the place that once gave birth to Atlas, a faraway system with its own planets, its own sunlight, its own beginning. Over time, these particles began to spread out, their orbits stretching wider and wider until they blended into the endless cloud of interplanetary dust that surrounds the sun. To the naked eye, they are invisible, but when sunlight scatters through them, they create a faint glow in the night sky, a ghostly band called the zodiacal light. In that glow, hidden among countless local particles, there may now be dust from 3I Atlas, a tiny drift-in connection between two star systems. Astronomers believe this process happens everywhere. Every time a comet breaks apart near a star, its remains are swept into space and slowly join the galactic dust streams that flow through the Milky Way. And when that dust settles again, pulled by gravity into the birth clouds of new stars, it becomes part of something new. The atoms that once belonged to 3I Atlas might someday fall into a collapsing nebula, mixing with gases and ices from other worlds, forming the seeds of a future solar system. Perhaps one day a new planet will form from that mix, and on that planet a new kind of life may emerge. In that way, nothing in the universe truly dies. It transforms, it drifts, it becomes part of something greater. This is the cycle of cosmic creation. Stars give birth to planets, planets give birth to comets. Comets scatter their dust, and that dust becomes the foundation of new stars. It's a slow, endless rhythm, one that spans billions of years, a rhythm that connects every world to every other. The dust of 3I Atlas may be ancient, but in its journey lies the future. Somewhere out there, light years away, that same dust could now be falling like soft rain into a cloud of forming stars, quietly adding its memory to the next generation of worlds. And so our story and its story continue together. Because when we look at the night sky, we're not just seeing stars, we're seeing history, the recycled remains of everything that has ever been. Every breath we take, every atom in our bodies was once part of a star, a planet, a comet, or perhaps even something like 3I Atlas. The atoms that once belonged to 3I Atlas were all forged long ago in other worlds and sent into space through explosions, collisions, and the quiet drifting of cosmic dust. We are the continuation of that same story. We are made of the universe, and the universe is made of us. So when 3I Atlas turned to dust, it didn't disappear, it simply went home. Home to the galaxy that made it. Home to the vast ocean of creation that will someday use its atoms again. And maybe, far in the future, some curious beings will stand under another sky, look up at their own stars, and wonder where their dust once came from. And part of that answer will lead back here, to us, because the dust of 3I Atlas is now part of our story too. The story of 3I Atlas began in the silence of deep space, and ends not in darkness, but in light. For billions of years, it drifted between stars, cold, unseen, its journey without purpose, its destination unknown. Until one day, by the quiet pull of gravity and chance, it crossed paths with our sun and became, for a short time, a part of our story. Its visit was brief, a flicker of motion through the endless night, but in that fleeting moment, it changed how we see the universe. Before Atlas, we thought of our solar system as an island. After Atlas, we understood that we are part of a cosmic ocean, a place where worlds drift and meet, where dust and life are shared across the stars. The darkness between the stars is not empty. It is full of travelers, full of silent messengers, carrying the stories of countless suns. And among them, 3I Atlas was one of the first we ever heard from. When astronomers studied its dust, its orbit, its chemistry, they realized something profound, that the universe is connected in ways too vast and too quiet for us to see all at once. Every object, every world, every human being is part of that same fabric. The atoms that once floated in the tail of Atlas might someday help form a new moon, a new ocean, or the breath of another living thing. In this way, nothing is lost in the universe. Everything continues. Everything transforms. We are surrounded by stories written in starlight. We live inside one. When we look up at the night sky, we are looking back through time, through the deaths of stars, through the birth of planets, through the long, slow drift of comets like Atlas, who travel not for purpose, but because motion itself is the rhythm of creation. There will be others, more visitors, more fragments from distant systems, passing briefly through our cosmic neighborhood. And with each one, we will learn something new, not just about them, but about ourselves. Because in their light, we see our own beginning. And in their silence, we hear the echo of our own journey. The universe does not rush. It does not end. It moves in endless circles. Dust to planet, planet to dust. Light to darkness, darkness back to light. And maybe that is what 3i Atlas came to remind us. That in all the vastness, in all the cold, there is meaning. A quiet, patient meaning woven into every atom, every orbit, every spark of light that reaches our eyes. When its last particles finally left the warmth of the sun, they faded into the galactic wind, joining the slow, invisible current that flows forever between the stars. And somewhere far beyond our sight, those particles are still traveling, still carrying the signature of our star, still whispering through the dark that they once passed through a place called the solar system, where beings looked up and wondered who they were. So when the night grows quiet and the stars appear above you, remember that you are not apart from them. You are part of them. You are made of the same dust that once traveled through space as a comet called 3i Atlas. And perhaps someday far in the future, our own dust will travel too, carried by light, drifting through eternity, telling the story of where we once lived and what we once dreamed. Because in the end, darkness is never truly the end. It is the beginning of something new. Another sunrise, another star, another traveler finding its way home.